Hello, everyone. Welcome to Unity's Creator Spotlight. I'm your usual host, Hassan. This Creator Spotlight is a little extra special because it's the first time we are streaming the Spotlight to both Twitch and YouTube. So we usually do this on Twitch. So for anybody who's joining us on YouTube, the Creator Spotlight is a show where we bring on incredible made with Unity developers for a rare in-engine look at how their games are built. So we feature developers who you don't usually get to meet, and you get insights that we don't usually get. And mainly, we get to look at everything that these developers were super proud of making. It's basically their time to show off all the great work they've done. Today, our guest is a little known game. You probably haven't heard of them. It's not really. It's Among Us VR, the hit game. It's a spin-off of the worldwide phenomenon that was Among Us. And we have 4 of the developers joining us today. For the show, we're going to be looking at a history of the studio, Schell Games. We'll then be looking at their design philosophy, how they brought the flat Among Us to VR. And then we'll be looking at some of the in-house tools that they built for creating mini games, their UI pipelines and VFX, and then we'll wrap it up by looking at their networking solutions. So before we introduce the guests and do all of that, let's look at the trailer for Among Us VR. Wait, okay, yeah. Okay, so we had a small technical difficulty with the trailer there, but we are here with the team. We have an emergency meeting. Hello, everyone. Welcome. Thanks for joining us. We'll play that trailer a little later as soon as we get that working. But yeah, I'm so glad to have everyone here. We'll do a little round of introductions, starting to my right. So, Michael, please go ahead and introduce yourself.
Yeah, hey, I'm Michael Lee. I'm a senior engineering manager and gameplay lead at Schell Games, and I worked on Among Us VR along with everyone else here.
So, pleasure to have you. So glad you joined us. And then Parker.
Yeah, hi, I'm Parker Ramsey. I'm an advanced engineer at the studio. I've been working on Among Us VR since day one, so I've seen the project go through all the highs and lows up till today, and I've worked pretty closely with Michael as the gameplay engineer lead, and the other folks here too. So happy to be here.
Very happy to have you. And then let's go to Abril.
Hello, I am Abril Martinez. I'm an advanced artist here at Schell. I've been also, like Parker, on the Among Us VR project since day one. I am a 3D technical generalist on the project, so I fill in any gaps that occur within the project, ranging from UI optimization, shader work, VFX, modeling, texturing, and even some concept work, with my main focus being on VFX.
Okay, I'm really excited to get a deeper look at some of those VFX. You teased some of them earlier, but can't wait to see it. And then last but not least, Dan.
Yeah, hey, I'm Dan. I'm a senior artist at Schell Games. I'm a tech artist and a journalist, kind of like Abril. I helped set up a lot of the UI pipeline in the beginning of the project, so I'll be talking a lot about optimization and sort of the thought behind that.
Okay, awesome. It's a pleasure to have all of you here. We're going to have a lot to look at for today's show. I think our audience is in for a special treat. Before we dive into the engine and looking at everything in editor, I'd love kind of just a high-level history of your studio, of Schell Games, previous games you've worked on, and how you landed on Among Us VR.
Yeah, so I'll be happy to talk a little bit about the history. So Schell Games is a studio. We're based in Pittsburgh, Pennsylvania, and we were founded by Jesse Schell over 15 years ago now. And, they've been doing a lot of games, but for the most relevant stuff, we we've been working in VR pretty extensively since VR first started bubbling up and becoming more and more popular. And so we've been working in different VR projects for over 5 years now, all the way back to like the original. Well, back then it was the Oculus Quest, but now the Meta Quest, right? And so we've developed a series of games, including games like I Expect You to Die. You know, we have Until You Fall, and then we also made the sequel, I Expect You to Die. We just announced I Expect You to Die 3.
We have
So,
some
we're-
B-roll footage of that we'll play on the side. Sorry, go ahead.
Yeah, so we've continued, we have really been working on sort of developing an expertise in sort of different ways people like to play in VR, what kind of games work, and understanding sort of the most interesting ways that VR can work in terms of giving players new and different and novel experiences.
Amazing. So, your most recent game before this was Until You Fall?
Yeah. So both
some footage of
Until
that.
You Fall and I Expect You to Die 2, sort of our most recent games. Dan actually worked on Until You Fall a lot with the effects, and that's sort of more of a combat-focused, like one-on-one sort of arena-based, really focused on different kinds of weapons and using the tactileness of VR and your hands to control and manipulate different weapons in these one-on-one combat encounters.
Okay, nice. And so, I guess you worked on those games, and then were you reached out to by the Among Us team to then start developing Among Us VR? How did it work?
Yeah, so as always with VR, there's a lot of people who have had, there's been a lot of interest, especially once VR started becoming really popular with things like, the Vive and Quest, etc. And what we were actually reached out to us by Robot Teddy, who works with the original developers of Among Us, Innersloth. And, they had been kicking around this idea of doing a VR version of Among Us, but, you can't just take the flat Among Us game and plop it into VR. There needs to be a lot of adaptation, a lot of things that need to get translated. And so those initial conversations led into a larger discussion, and that's sort of how we got started. It's like, oh, we think we have a way that we want to translate this to VR, and let's try it out. And people were really happy with sort of where the brainstorming led us, and that led into this longer-term partnership where we're able to build and develop the full game along with Innersloth and Robot Teddy.
So that's actually an interesting process. So you met with the team just to have some brainstorm sessions without having, let's say, signed anything, just to see how the chemistry was, perhaps, and to see what gameplay ideas would come up before you actually made it official?
Yeah, I'll say like, some of the people who are on the project earlier, Parker and Abril, can talk a little about this, but I do know, like, as going all the way back until even before the project was officially kicked off, there's a lot of like conversations, and once the project got rolling, we definitely met with the team at Innersloth, and they're really great to work with because they obviously have created Among Us, and they have a lot of strong ideas about how the game should work, but they were also wanted to, they gave us the freedom to say, hey, we are, we've worked in VR a lot. We have a lot of experience, not just here, but our designers on the project, people like like our design director Miha, we had designer Sean Patton and Trisha Sorve, who are really they came in and it's like, oh, we think like this is how this part of Among Us can translate to VR. Or here's something that we probably need to change, and they gave us a lot of freedom and flexibility to sort of take our expertise and create Among Us, but in VR, but not just a copy of the original game.
Okay, that sounds like a true collaboration. So they really trusted your team with your expertise. So that's actually, I think, really great on their part. So once you arrived at that, you mentioned to me earlier when we were talking that a lot of the tech and the work you built in your previous games kind of made its way to Among Us VR. So there was kind of a tech lineage, essentially, from your previous games to this.
Yeah, for sure. One of the things that we have built at Schell Games over the course of many, many different projects, especially projects built in Unity, is we have developed sort of an internal set of tools and frameworks that we can carry over from project to project. And so both, like, not just on the tech side, but on the art side too. So it gives us a lot of ability to sort of quickly ramp up, to start prototyping, not to worry necessarily about we got to reinvent the wheel every time we start a new project, but sort of jump in immediately, start playing around with ideas, giving everyone the tools to sort of start building in the basic building blocks for the game.
Okay, amazing. And we're gonna jump into looking at the design philosophy we're talking about, those conversations, get some insight into those conversations you had with Innersloth and how to translate what you call the flat game of Among Us to VR. I was calling it 2D, and you're like, no, we call it flat game.
Yeah,
like, all right.
Yeah, we internally I don't know how we just started calling it flat.
Yeah,
flat Among
it
Us.
just sort of came up at some point. The flat game.
The flat game, I love it. Okay. Before we jump into that, we do have the trailer working. So we are now going to cut to the trailer, and then we will talk about the design philosophy. So let's play the trailer. And we're back. Okay, there we go. That was the trailer for Among Us VR. We already have a very active chat, which was amazing. Thanks everybody who's watching and joining us today. Feel free to ask as many questions as you like. We'll be passing those questions on to the team. For example, Charlie Jones asks, how many developers worked on this? So we have 4 of you here today, but of course it's a much bigger team. So I'm curious how many people worked on Among Us VR.
I think at our largest, we were over 40 developers.
Oh, wow.
So that includes people, not just engineers, designers, artists, producers, audio, but also, a lot of this support staff. We have a really amazing QA team here. One of the things you don't think about for Among Us is we support up to 10 players, so you need at least 10 QA people to be able to test the full game.
That's a good point. At all times.
Yeah. So, and we're continuing development, and our core team is still over. We still have a good sized team that's continuing to build updates and future cool things for players.
Wink, wink, hint, hint.
Mm-hmm. Yeah,
cool things.
Some things have already been announced, and even more things have not been announced. So.
Okay, that's always good. So as we teased before the trailer, we said we're going to talk about the design philosophy behind taking the flat game to VR. So I think, Parker, you're going to walk us through a bit of that, the thought that went behind that. Yeah, go ahead.
Yeah, for sure. So like I said, engineer on the projects. So not 100% on the design side, but I picked up a lot of it through osmosis over the course of developing the game,
Yeah.
working directly with the designers over time. So yeah, like we mentioned, we were moving from a flat game to a first-person virtual reality game, which is a pretty big paradigm shift. One of the biggest things you'll immediately notice, obviously, is you don't have this sort of 360 view of complete understanding of everything that's around you at all times. And that changes how you play the game. You have to sort of handle the fact that players don't know who's behind them. That even on the flip side, players can now see directly all the way to the other end of the skeld even. So we tried to play with sort of the fact that we're in VR to provide sort of new and still engaging ways to play Among Us. The tasks in particular were changed pretty dramatically. We tried to give you like sort of solid actions to be doing with your hands, like hitting buttons, pulling levers, pumping
Right.
pumps.
Yeah.
Yeah, I guess one small example for tasks is the retina scan minigame. So that's one for those who don't know. This is a minigame. It's essentially like a terminal on the wall you walk up to. You just have to stare at it straight at the wall for like a solid 5 seconds or so. And obviously, while this is happening, yeah, like people can be sneaking around behind you. You can like be hearing footsteps. Maybe a vent is opening or something.
Yes.
And if you turn away, you immediately start losing progress. So it's like trying to build that tension by utilizing the lack of complete omniscient awareness of your surroundings.
And that's such a simple gesture, just forcing someone to stare at a wall, keeping them in a very vulnerable state.
Right.
I love that. I feel like instead of looking at it as a problem, you really saw all the opportunities that come with VR, rather than be like, okay, wait, so you can't see the whole room anymore. So how do I do that? You're like, okay, so you can't see the whole room. Like, what are the benefits that can be pulled out of this? And that minigame is a perfect example of that. It creates these you put these players in all these situations. When you were tackling the design, was it being thought of in like vignettes of these moments, like feelings you wanted to create, or how did you approach it?
Yeah, interesting question. I do think we wanted to try to use VR to create as much fun as we could, like new fun. Like I think something that just occurred to me is the idea of like hiding around a corner is really fun in VR. You can sort of like peek around a corner and like look at someone and then hide back before they see you. That's tons of fun. I guess one specific thing that we use as sort of a guiding principle a lot of the time when thinking about what sort of features we want to work on, what to include, what not to include, is this question of, does this thing service the social deception gameplay of Among Us? So that sort of like lying, sleuthing as in a crewmate to figure out who is the imposter is the sort of the meat and potatoes of the experience. So anything we were working on, we would sort of sanity check it, like, is this serving social deception?
Right.
And I guess the retina scan is a good mention there too. Like, it utilizes the field of view specifically to sort of heighten that sense of who's the imposter? Am I in danger right now?
Yeah. And did you find that the physicality of the tasks adds to the suspense and pressure of things? Because I feel like it's a different thing, you like pointing and clicking versus like quickly pumping a pump while you're nervous that the person behind you might be like the imposter.
Yeah, that's a fun thing to bring up. Definitely certain mini games you can get into, and if you feel like you're in danger, you're definitely like trying to pump that thing as fast as you possibly can. And alternatively, things that you can't speed up, like the retina scan I mentioned, or there's a download files task that you just have to wait for the download to proceed, which was also in the flat game for those familiar. Definitely that sort of ratchets up the tension. We also have this like whack-a-mole game where you're just sort of hitting little what are they called, head slugs, as they pop up out of a terminal. And yeah, definitely like slam those things as fast as you can. which we have some tricks for on the dev team, but I won't.
Okay. You
I
won't share here.
share how that works. Yeah.
Were there any particular challenges that came from moving from flat to VR? So obviously a lot of opportunities, but was something particularly challenging that you had to address in through design or tech or something?
Interesting question. I think one of the biggest challenges, which we can talk about more later on, is probably handling the performance in VR. Big hit for doing this large 3D environment with like a ton of players. Another challenge is sort of knowing what to cut from the flat game. Like a lot of the flat game seems really iconic, but we needed to sort of not include all of it. I'll give, I guess, one example. In the flat game, there's a card swipe minigame in admin. This is a common task. A lot of people note if you played the flat game, it's you just sort of swipe a credit card, basically. It's an ID card, but imagine swiping a credit card, and you have to swipe it at just the right speed so it'll go through and accept it. And we cut that task, even though it is fairly iconic. The reason we did that is that technically it didn't really jive with the way we were constructing mini games, which we tried to keep fairly modular, and that would end up being a fairly sort of one-off, unique experience. And because it didn't necessarily service social deception on its own,
right?
And it was also this sort of tech lift that we didn't necessarily have to do, we ended up cutting it.
I see. Okay, so you had to make those kinds of difficult decisions, and then when it comes to things as simple as movement, right? That's always maybe one of the first things you have to tackle when you're building a VR game. How are we going to make people move around this environment and not have them feel nauseous? So I'm wondering, like, what were your direct solutions to? What ideas did you bounce around before landing on what you landed on?
No, great question. And I can talk to that directly a little bit. I worked on a lot of movement prototypes really early on. So basically what we did is we tried to find like all the different ways that people move around in VR, like different, predecessor examples. We have teleporting, obviously, in some games. Some games you like literally move your arms like this to move forward.
Right.
So we basically made a prototype for like all of these different types of movement and tried to see which ones would work in our game and which ones wouldn't. Some of the more common ones were an issue for the design. Like teleporting, for example, is a super common VR movement type, but it doesn't make quite as much sense trying to put that into this sort of social deception 10-player VR game where you need to, I guess, sort of track people's position a bit more reliably. Like if you're trying to kill someone as an imposter, you don't want them to just teleport away.
Exactly, right? That's a huge challenge, yeah.
In terms of motion sickness, which is a pretty big issue in VR, typically, we tried to go the route of just giving the player as many options as we could to mitigate this, because everyone's experience is different regarding motion sickness in VR. So we have something called a vignette, which is essentially when you're moving, it can reduce your vision to sort of this little circle, like a periscope sort of in front of you, and everything outside of that circle is masked out to a sort of stationary room.
Yeah.
And that helps you feel like, or it helps your brain anyway, feel like you're standing still in this room while you're actually moving through space. We also give you options like, do you want forward to be the direction that your character is facing or the direction that your head is facing? And that's another thing that, like, some people are one way, some people are another way. I'm definitely a forward is whatever I'm facing person. Let me think. One other sort of motion sickness mitigation technique is how we turn.
Okay.
Yeah, so I guess for those who aren't aware, our movement is smooth. So you just press the joystick and you slide across the floor. Right. There's no teleporting. There's none of this going on.
It's more traditional.
More traditional, yeah. And like traditional games, you can use the other sticks to sort of turn your camera outside of just turning yourself in the real world. And we provide two different ways to do that. You can use smooth rotation, which
Mhm.
means it, like a typical video game, it'll sort of smoothly lerp the camera from one position to another, or sort of snap rotation, which snaps based on a set of degrees, like maybe 15 to 45 degrees that you can set in the options.
Right.
And that helps reduce motion sickness for a lot of people, not having to sort of watch this smooth rotation. I personally can't handle the smooth rotation, but some people are smooth rotation only players. So
Interesting.
yeah, really the core is just giving options.
Right. And so that's something I guess you've learned as a studio over time, is that there's no one solution that fits all for VR players, I guess. You have to provide options.
Yeah, I would say so. It's really hard to find a sort of one-size-fits-all fix for motion sickness in VR. Just more options, the better for players.
Yes. I mean, even if there was a one option that fits everybody, it's still good, I guess, to give those options, because it might just be a bit more comfortable for some players to do
For
it
sure.
one way versus another. Okay, great. Another thing that I wanted to point out that I loved was the difference between flat Among Us emergency meetings and VR Among Us emergency meetings. Can you talk to that a little bit? Just
Yes.
the pointing and all of that.
Yeah, 100%. So this was
please.
another thing we talked a lot about early on in development, is sort of how do we want to handle the discussion section of the game, because it's the main draw is like talking to your people, and we felt like we couldn't resist the idea of like putting everyone in this room together so you can all like see each other's hands, like point at each other,
Yeah.
like gang up on each other, like someone can go hide in the corner of a room if they're feeling, too singled out, I suppose.
Right.
So yeah, it was something we debated a lot. Like, how do we want to vote? How do we want to have that discussion play out? One thing that we talked about early on was sort of the method of voting. Like, the pointing is something you called out, that it is pretty fun. But we didn't want to necessarily bake that into the gameplay. It was something we discussed at one point, is using pointing to like vote. Like, everyone point at the person you want to vote out of the Skeld. We thought that might be a little bit too intense for some
Yes.
players, so
Yes.
we wanted to keep it sort of relaxing, to some degree, as far as being voted out of a ship can be, and not sort of force players into an antagonistic scenario if we didn't have to.
Right. Right.
So basically trying to keep it fun as much as we can.
I think that's a great decision, because now you get to point without as much consequence, and
Right.
you get to do it just as a fun thing. And also I guess it's not a great feeling being pointed at by 9 other people. A bit scary, maybe.
Yeah.
Before getting thrown out of the ship.
It
But
can
yeah.
be fun when it happens organically, but
Yes.
try not to force it.
Yes, exactly. No, I love that. And I think this was, I can imagine just being given this opportunity to just drop 10 people in a room and have them vote each other out. You're like, yeah, we have to make this an in-person thing. I absolutely
It's
love
so
that.
fun.
Yeah. So yeah, I think now would be a great time to jump into the engine. Everybody in chat has been asking, when are we going to look at engine? When are we going to look at engine? We're going to do it now. We're going to look at the tools you built, first of all, for building the tasks. So I think we're going to be sharing Michael's screen for this one. We'll cut to Michael's screen and walk us through your modular approach to building tasks. Let's cut to that screen right now.
Yeah.
There we go.
Cool. And
it's live.
yeah, so as Parker was talking, like both Parker and me and a couple of other engineers, we were tasked with a lot of the gameplay systems, and one of the key things you do in Among Us is you're engaging in these tasks, or we call them mini games here. So you can sort of see, like, for example, I'm in the reactor room right now, and you can see our tasks are highlighted by these yellow circles, which represent sort of the engagement zones. So you can see, like, here we have the classic reactor Simon Says minigame that everyone loves or hates. We have like the numbers minigames, and we have sabotages, and we have these scattered throughout the ship. So we have a bunch of these minigames. I think we have we definitely have over 15 minigames, and it would be it would be difficult and also sort of foolhardy to like have each of these be a custom implementation. So one of the things we decided really early on is like these mini games needed to be modular, not just for development purposes, but also to give designers the freedom to
Right.
build, rebuild, and iterate on. Because these mini games went through a lot of changes. Like if people know, like for example, Simon Says, typically in the Slack game, this is actually there's a lot more buttons here. And here, because of VR, we simplified it down to just 4 buttons, which you get the same experience, but it means it's not quite as complicated, and people are able to like divert their focus while they're playing the game in and out of instead of just getting tunnel visioned on here.
Okay.
And so let's jump to, I think, one of the more well-known games is Repair Shields. Where are you? You're over here.
Yeah, we have a question from the chat. The chat is trying to settle on whether to call them mini games or to call them tasks.
Oh
So-
boy.
Oh boy, the official terminology is
Kinda
tasks.
Okay.
We just call them mini games because they are mini games to us.
Right.
But yes, they are officially they are tasks.
There's tasks.
Can I-
Gotcha.
Can I hop in there, Michael?
Yeah,
This
please.
is something like I went back and forth on this for so much time, and I feel like I developed my own vernacular that I've been trying to spread to the team as much as possible.
Mhm.
Basically, this is how I do it. You struck a nerve with me. So we have mini games and tasks. A task is a collection of mini games in sequence. It can be a single mini game or it can be multiple mini games.
Oh, interesting.
Right. So there's like a download files task that says, hey, go to this terminal, download files, and then go to the second terminal and download files over there as well. That's 2 mini games, one
task. Gotcha.
Yeah.
Okay.
Now you
That's
know.
fair. That's fair. Now you know. Take that, chat.
Yeah.
Okay.
Yeah, and
Cool.
so one of the things we really focused on early on is making sure. So we, for example, we have, if you can see here, we have this custom inspector for, in this case, MIDI games. And a lot of these are driven by like just dragging in different parts of the components. We are using Unity events here for different actions like on engage, on disengage, when the minigame resets, when it's assigned, when it's completed. So this allows us to do things like our sound designer can go in and they can just hook up sounds on certain things rather than us having to like hard code those in.
Right.
But as Parker was mentioning, we like tasks are composed of multiple minigames.
Mhm.
And one way we made sure that happened was we wanted to utilize scriptable objects pretty heavily.
Okay.
And so for example here, we have this
Can you widen that window just a bit for the for everyone in the audience to know what we're focusing on? Just the
Yeah,
inspector window? Yeah.
Yep. So there we go. So you can see here, like each minigame has a data object, in this case a scriptable object associated with it. So you can see like we have shield repair data, and this is pretty simple. And you can check mark a couple of parameters here. Like, is it a visual task? Is it a sabotage task? Is it an exclusive task, meaning only one person on the ship can do it at a time?
Right.
Which a couple of our mini games are like that. And then if we go here, we can see we have our tasks. So you can see our tasks are divided in a couple of different ways. So a very classic one, as Parker was mentioning, was the download files task. And you can see like this, we have different sequences. And these sequences, again, it's its own scriptable object. And these are composed of different elements. And here you're chaining together the mini games. So here, for example, the download task is composed of a download and upload task. So you have to download it in a random location. I think there's 4 different locations in the scaled, Parker.
That have the download files task
Yeah,
for minigame.
I think it must be 5 because there's 5 elements here.
Right. Yeah, I guess to shout that out for everyone's clarity here. So there's these 5 different sequences, each one containing 2 mini games, upload and download. And the reason that there are 5 different sequences for really the same 2 minigames each is that each one denotes a specific location as well. So it'll say start here, then go here.
Yep.
For each of these 2 different minigames.
Yeah, so you can see here, for example, the first one is start the download in cafeteria, and then and for upload, in this case, it always ends up you upload in the admin room, which is the central room in the game. But again, with this tool, you could easily go, and our designer could have created a second upload location, and then you could just add in, and that now these sequences would be different. And the way this works is for a task, if you're assigned this task at the start of a round, then it will randomly select one of these sequences that you need to complete. And that's how we handle the randomization of tasks.
Oh, interesting. Okay. And so then that's how you handle the randomization. But for my also 80% of the minigames are built in editor, right? And not, but I guess that means some of them are built custom still by the developers.
Yeah, there's a few that are custom. Yeah. But one of the things, and this is tying back to something that we brought up when we were talking about the history, is like we, over the course of building a lot of games at Schell Games, including VR, we have developed a number of tools, and one of them is a visual scripting solution that we like to call a vignette editor.
Okay.
So sort of like using visual programming nodes.
Yeah.
So for example, here's our shield repairs. So if people don't know, with shield repairs, what happens is like when you're assigned this task, like 4 or 5 of these buttons will be lit, but you need to turn on all the other buttons. And so normally you think like, oh, we need to go through and we need to like, okay, assign each of these, and then we'll write a script to randomize it. But instead, with our visual scripting language, so if we open up our graph here, so all of this is done in our custom tool vignette editor, which was made over many engineers and many game projects.
Wow.
But you can see here, like this handles all the logic for how the shield repair works, and it's been highlighted into different sections. So for example here, this is the initialization part. So you can see like you're going through, and what we're doing here with these dice rolls is we're randomly assigning which parts of the graph are going to be lit up.
Okay.
And then once that's assigned, and then we have like some cleanup here, we actually go over, and this is the core logic. And here, all it's waiting for is like, as these turn on, we're gonna wait in a chain, and we can go and once everything is completed, the mini game is completed, and then that task is marked as successfully done. And the cool thing about this is like we as engineers, like we might need to go in and maybe make a custom node or two,
right?
But this was all done. I think I believe Trisha was one of our designer who worked on this, and she built all of this logic just herself, and she was able to like go in and like, oh, maybe we should extend it out so there's like multiple random passes, and these are all things that they can go in and they can make quick and easy changes with.
Okay, and so this is more looking at the overall structure, right, of the tasks you have to complete and the mini games.
Yep. And then to sort of tie back into the more modular as you're building, so you can see here we have like the mini game parts, but we also have these individual task components, right?
Mm-hmm.
And again, these are all if you can tell here in the hierarchy, because of they have the blue cube, these are all prefabs. So these are all standard mini game buttons, and our designers can go in and they just basically built this tool by dragging and putting these buttons in piece by piece.
Yeah.
And now all these pieces, once they're in, they're able to connect using a couple of different tools. So for example here, we have what we call global variables. And these variables then tie in to our mini game system. So you can see we've sort of listed, and this is how we can tell, for example, like button 1, button 2, button 3, 4, 5, 6, 7 are all toggled on or off. And so once these are tied in, all our designer or all Trisha needed to do was go into Vignette Editor, make sure these are listening for those bool variables.
Mm-hmm.
And once that's all done, then the minigame logic is completed. And so this is sort of basically how we went and built 80% of our mini games. So if you go, you can see like we have all the mini games here based upon different areas. But for example, if we go into like the download task mini game, you can see this is a much simpler one. But you can still see we are using the same component here for the minigame buttons. And this handles, like, just in this case, it's a single button interaction. You click here,
Right.
and now you're just waiting for the download bar to complete. So we have a download timer, and once that timer is completed, then this part of the minigame task is done.
So I have a question. So are those, so like the download timer, for example, the button is a prefab that you already have for the designer. The designer puts that in. I guess they work with an artist to design the button. So they're like, hey, I want my button to be a hexagon like the previous one, or this download button, right? You plug that in. And then to get things like the timer or to those things that really make the variation, or these buttons need to be hit in this specific order. That logic, how is that logic being built? Are those also from nodes that you've built for the designers, or are those then requests that are made to the developers? Like, hey, I need this. Once I click this button, I need a 1 minute timer to go down.
No, those are also all nodes.
Oh, nice.
So that's sort of the beauty of the system. So here
Yeah.
we can see the much simpler graph for download timer. And here, I think what we needed to do is, so here we have like, so we are, if you start, you can see like we are setting like a random time, and then we're making sure like a couple of booleans are set. But then our designer, all they needed to do was like, they say, okay, the timer starts, and they just wait. And once the timer hits a certain point, then they know the game is completed. So basically we're waiting here, we're completing, and then at this point the timer has been completed, so it's counting up and it's finished. And so stuff like this, like we as engineers, okay, like what will happen is the designer will try to build these games as much as they can with using the nodes we've already built. So if you right click here, you can see like we have like a lot of different nodes that we have made over time. And again, these are all custom Unity editor tools that have been really helpful. But once they are done, like occasionally they might need to request to us as engineers, oh, we need like a new kind of node, or it would be nice if a node encompassed these actions or were allowed for these kinds of hooks. But once all that is in, the great thing is, because this is a tool, a modular tool, we just need to write that node once. And then the designer can then start reusing it. And we've seen a lot of times where designers will take a node that we've created and sort of run wild with it and use it in different mini games for things we didn't even anticipate.
Yeah. And I think that makes the workflow for the designer a lot more fun, because they can think something up one night and then come into work the next day and just try it right away without having to wait to see the result, right?
Yep, exactly. So we've had like a lot of these games. So I think another one that uses it is I think this one does this oh my god, Unlock Manifolds also handles it in a similar way, where we have like, again, once you start looking at the mini games, you have the same setup, you have the mini game buttons, and you're able to build out the graph in much the same way.
Okay. And how do you handle something that's not quite a button, but is more of an input, such as pumping the pump?
Ooh. Parker, do you want to talk about that while I go look for where?
Sure. Yeah. So Everything
are.
that's not a button, for the most part, is considered a lever. It's the sort of the other tool in our arsenal. So the pump is a lever. The sort of there's a reactor mini game where you move something left and right. There's a navigation one with 2 different sort of knobs. So really, buttons and levers are the 2 tools that we have to cobble together mini games. And you see it's using this linear motion script that sort of handles all of the logic under the hood for how these things should behave. We've also worked on, I don't recall if this exists in the Schell map, but there is a rotational motion tool that we've put in more recently.
We do have those. Those rotational motions are used for these levers.
Awesome.
So not linear, but ones where you have to sort of rotate them around.
Right. So we've got sort of obvious like hit button interactions, and then things to handle these more sort of VR, like take an object and manipulate it type of interaction. So the designers can hook those in when they feel makes sense.
Okay, so you basically pre-built those inputs and scenarios and allowed, again, same concept, but different implementation.
Yeah.
Right. And we try to keep the interactions sort of as generic as possible so they can be used in like a wide variety of different ways.
Yes, that makes a lot of sense.
Yeah, so for example here we have rotational motion on these up and down levers, but we're using the same thing here on these left and right levers, and then I think our most complicated version of this is at navigation.
With the 2 levers?
Yeah, well we have one here with the
this one. Okay.
Yeah, with stabilized steering, which uses 2 levers in both the X and Y directions. And you can see here, like on our rotational motion script, we're doing a lot of stuff with not just where it interacts and starts, but you can also like lock the rotations in to different axes, and then you can track that rotation with the float variable. And once again, this float variable is tying directly into our minigame, our minigame vignette setup.
Okay.
Yeah, definitely want to shout out the variables. They can be used for so much stuff, both logic, and you can listen to them to sort of affect visuals as well, or trigger animations, or any game events you need to happen.
And so again, I guess the designer will have these nodes and all these tools built by the programmers. They'll implement something, and then they'll work with the artists and animators and tech artists to kind of create the visuals that they're looking for. Is that the kind of the flow?
Yeah, I think typically when we're making a new mini game, we do start out with a very sort of white boxy, you know, big red buttons for the buttons, just to sort of get the logic down and make it sort of a playable experience. And then like you said, we sort of add in all the art, hook in all the effects afterwards.
Of course. So you test it, see if you even want it to be part of the game, and then put in the work of prettying it up, polishing it up.
Right.
Okay, nice. We have a great question from the chat asking, was any of the game's code pulled straight from the flat game, or was everything built from the ground up?
So for our game, it's actually really funny. We thought, oh, maybe there's parts of this that we could copy, but what ended up happening was our minigame system is built so differently that there's no code crossover from the original game at all.
Gotcha.
Yeah, and that's because of the way like all of these buttons are also handled. They need to handle like their own unique interactions that are triggered by the hands, because we're all hand or we're all VR. As a VR game, we're all hand based. So the setups for both of these are entirely different. Sort of the flat game Among Us, it's almost all entirely. You can think of it like all the tasks are basically UI elements here.
Right.
All our tasks are sort of in-world elements. Okay. And so we did definitely look at the sort of high-level logic for a lot of games that are similar, like, again, download tasks and such, but because we built it on top of our unique system, it ended up being just entirely different. So there's no there's no code to code sharing.
So you
unfortunately.
It would have been nice, right? So you looked at some of the old code for inspiration just to see how it was done, and then you tackled it in your own way that suited the VR gameplay.
Right.
Yeah. Okay, great. Another question from Zephyr Lai asks, can you trace the changes of the graph on Git?
Oh, yes.
Like the nodes? Yeah, back to the nodes. Actually.
Right. So sort of looking at the history of it. You can. Now that I think about it, that's never happened. But you can definitely, because these are all scriptable objects, right?
Mm-hmm.
So because they're all scriptable objects, you can go through and like any source control, you can go through and you can see the version history, and you can definitely roll back. So we've had instances where people have made changes and are like, I like the old version. And so what they've done is then they just roll back to a previous iteration of that game.
Okay.
Right.
So
and
stuff like that has happened.
Just to shout it out, if you are trying to debug these sort of vignette graphs, at runtime, we do have a feature where you can sort of watch it walk through the graph in real time. It'll show you, like, it'll highlight which node is currently executing. And you can also click into it to sort of access the variables that it's depending upon to check the variable's value. And the variables will tell you their history at runtime as well. So we do have a lot of sort of runtime debugging tools to help you figure out what's causing the graph to execute the way that it is.
Gotcha.
Yeah, you can see like here as I'm clicking through, like these nodes will get highlighted, and you can see in the inspector we're exposing what variables are being attached here and what things could be changing. You can also see like one of the nice things, because it's true visual programming, so you can have like branching statements, etc. You can see like what children it connects to.
Yes.
And then if the game was running, you'd see like the active runtime here, and you can see all the different variables that are being used in this graph currently.
Okay, great. So I think being able to see which node is currently active, as you said, is fantastic for debugging to see if something's going wrong or what is going wrong. Before we jump to a break, I would like to ask, since we're on the subject of tasks, I'm curious, what is everyone here's favorite task?
I've got my answer locked and loaded.
You know it already? Okay,
yeah.
I guess you all have your answers locked and loaded. I'm curious how much overlap there is. So lock in your answer, no changing. We'll go, Michael.
My favorite task is definitely medbay scan.
Okay.
This one it's a very simple task because it's all you do is you stand here, and this is one of the few both exclusive and visual tasks. And so you can see here, like,
we'll go back to the screen. Sorry, we went to.
Oh,
yeah.
Like you can see as you're getting scanned, there's like a little highlight that appears around you. And let's see if I can find it. Yeah, so you have like these little visual effects. And so I always find this fun because this is such an important, like sort of a classic mini game. I love the way that it was translated, so you can see like the visual highlights happening around you while the game is playing, and then you can also take control of it yourself. So
okay, gotcha. So, and this is a classic one. I remember from the old game. Okay, so Parker, you said you already had yours locked and loaded, so
100%. Yeah, it was one that we actually looked at just a moment ago. It was a game in navigation that has two different levers that go in sort of different directions. I enjoy that one so much. Just the action of moving two different levers at the same time to manipulate the screen and sort of get your crosshair where you want it to be. It's sort of like playing with an Etch-a-Sketch now that I think about it. But anyway, I just really enjoy that sort of tactile action and being able to use both my arms to play the game. It's a lot of fun.
I love that. Abril.
I really like unlock manifolds, mostly.
Oh, you're muted.
Oh, am I muted? Is it going now? Oh, okay. Are you able to hear me now?
No?
Yep.
You can? Oh, sorry. Okay, go ahead.
Okay. I really like unlock manifolds just because I can press with multiple hands at the same time. So I can do it really, really fast. and that just makes me feel really cool and like a really good crewmate.
Okay, and then Dan.
Yeah, I think my favorite one is probably sort of the two mini games in the reactor with the hands. Just because it's always like such a simple thing to do, but when you're doing it, it's so like nerve wracking, and then you have to like go around the corner and you lose. I mean, it's like that in the game too, in the flat game too, where I mean you kind of walk out of the view. But I think in 3D when you're going just around the corner, you're like, you don't know what's gonna happen. I think I really like that.
Yeah. That's great. Well, chat, let us know what your favorite task is. Drop it in the whether you're in YouTube or in Twitch. Let us know what your favorite task is. While we are on break, we'll be back in about 5 to 10 minutes, and we have lots of questions in the chat about shaders, networking. We're gonna cover all of those things as soon as we're back from the break. We'll be looking at the UI, the VFX, and the networking at the end. So stay tuned for that. We'll be back in just about 5 to 10 minutes. Go get some snacks, some water, take a washroom break, get what you need. We'll be right back. Ciao. And we are back from the break. Hope everybody had a great break, chat. But if you weren't with us before the break, we looked at the history of Schell Games up until receiving Among Us and working on that. And then we looked at the design philosophy of moving from the flat Among Us to the VR Among Us. And then at the end, we talked about building the tasks and the amazing modular system that your team built for creating tasks and empowering and enabling your designers on the team to build the tasks themselves in Engine. And we promised that we were going to then look at the UI pipeline. So that's where we are now. So Abril is going to be sharing her screen, and Dan will walk us through some of the optimizations that they did for VR. So Dan, take it away.
Yeah, I guess just to start off talking about UI in general for this game. So if we think about like the flat game, there are a lot of different parts of the UI, like let's say the name tags, the mini map, the task list, the voting screen, not to mention like the setting screens where you can change all the game options. So I think when first joining the team, it's like, oh yeah, Among Us, that's a pretty cool game. And when you're playing it, you actually don't really notice the UI as much. It's kind of like a seamless interaction, right? And then, but when you're making the game, you're like, oh, this is all UI, like everything, including the mini games, all the settings, it's all UI. And so in this game, it's a little bit more complicated because it's not just flat UI. You have a lot of 3D elements. And so we had to come up with a system that allowed for not just like flat UI, but a lot of things that could interact with these 3D elements. And then alongside of that, so we are on a bunch of different headsets, right? And so these are essentially like mobile platforms, taped, strapped to your head. So things have to be pretty optimized. And so with a lot of these 3D assets, so we're not using the Unity canvas. A lot of these are just our own hand-rolled solutions.
Okay.
And so there's two sort of general pipelines. I'm going to talk very generally before we dive in. And one is we just model the whole 3D asset. So you can see in this screen share that Abril is sharing, like this is the mini map. It's all just modeled in. So that's sort of one way we do it. And then another way we do it is we sort of do it by element, where let's say, oh, you have a panel or a button, and those are reusable. We can, model those and then reuse them as needed for UI. But just to dive into here. So this is like a preview of sort of the raw model of the mini map. You can tell it doesn't look like the mini map in the game. There's like a lot of meshes here that are visible compared to when you're in the game. And so a lot of this is actually controlled in the game by the shader. So we're driving a lot of behavior through shaders. And so, so on the side here, we have a bunch of properties that we're reading from the shader. And the shader drives a lot of these different kind of things that basically different kind of behaviors. So you can like toggle different meshes on or off. Things could potentially animate, change color.
Oh, interesting.
This is including things like sliding bars. And so there's any number of behavior that we could potentially build into shaders. And so a lot of this has to be sort of very hand-rolled. We have to work very closely with the UI artists, the designers, to make sure it has all the behavior that we want.
So when tackling the UI, what made you choose to go this route of having it all done on the mesh in shader rather than doing like a more typical canvas that's in world space, maybe following you around?
Yeah, so if you think about this piece of UI, so let's say you have some panels, you have like the loading bar, you have the map, you have different buttons, you have different icons on the buttons. If you're building this in Canvas, these would all be essentially like separate draw calls, right?
Right.
You have to render all these things. Could be, and for everything you have to add, you're basically adding to the cost of the drawing. Canvas also has things where, if you're animating certain things, it will cause the canvas to redraw. And so we want to sort of avoid all of that. And so by having it in a 3D mesh, we are changing it, the properties through the shader, but it's all just one draw call. So that's like pretty significant in terms of optimization.
I see.
So the shader itself might be like a little heavy, but I think the trade-off there is pretty much worth it, especially if you're going to be, using this mini map all the time.
And is this a solution that you've used in previous projects, or did you come up with this just for this project?
Yeah. So I guess before I joined the team, I was helping out with optimization on I Expect You to Die, which was like the spy escape room game, and then also Until You Fall. And so one of the major work I did in Until You Fall was optimizing the VFX and the UI there.
Yeah.
So with Until You Fall, we had first built it for the PC. And so we had to think about some creative solutions to sort of think about, how do we reduce these draw calls, overdraw, transparency for VR heads, for like the portable VR headsets. And so I was working with a lot of the senior engineers there, and we basically came up with a solution where like, okay, so we can basically like remodel all the UI as a 3D model, and then we can all just make it like one draw call, and then drive it with the shaders. I think this was definitely maybe a sort of unexpected solution. I think it is a lot of manual work, but the amount of control you have is like it's very good.
Yeah, I love I think it's a very creative solution, actually. And we have a great question from the chat asking, how do you handle text on this?
Oh, text is another thing. So we have several solutions for text. So if we know that there's nothing, really going on in the game, you could just use like Text Mesh Pro, Text Mesh, and that would be fine. But when you're in game, when you have, a bunch of skin mesh renderers, characters, crewmates running around. So what we do is our general solution is we bake all the text into render textures ahead of time. So you can see here's like a little secret area of the game where all the text is. And so we basically lay out all the text that we need ahead of time, bake it out, and then it's essentially, so it's a render texture, but it's essentially a text atlas. And then this will be referenced in the shader as essentially a texture. And we are laying out this text very specifically. So we will know like what the UV offsets are, where the text is in the texture. And then we'll sort of, it's like a little hard coded, but not completely. So for example, if you see like the player names there, essentially they're just in a row, right? So if you imagine the player mesh, you can sort of move that mesh onto where that name is in that specific part of the mesh. And then, depending on what player you are, it will just move that mesh in the UV space down, so that it's the right display.
And for usernames and all that, it'll generate the text at the start of the match with your name, and then render that texture on top of the player.
Yeah. So here you can see Abril pulled in a sample texture, which was like kind of what that baked out atlas would be. You can see when we're doing it live, we do measure like the length of the name and resize that mesh in the shader accordingly. So there's a lot of like background logic that's going on there. So there's a lot of control to make sure things are visually the way we want it. Yeah.
But that sliding happens automatically, right? It measures the length of the text and then adjusts.
So Abril is doing it manually in the shader now, but when we're running the game, there's code that checks it and then resizes it according to the
Okay, amazing.
text. Yeah.
And is that just like a vector graphic you've imported yourself, or that's just drawn with shaders, right?
Yeah.
like
So
capsule.
the name tag itself is a mesh, and so those vertices at the end of that name tag there.
Yeah.
So a lot of the strategies we're using to get a lot of this data in is using vertex colors.
Okay.
And so a lot of the vertices at the end are colored specific vertex colors that we then check in the shader, like, hey, are these vertices the vertex color we want? Oh, okay, they are. Okay, then we can move them to the right or to the left, according to the size. So you can see here, if you notice in this name tag, there's like a rectangle cut out. And so that area specifically, like, that area is specifically where the name tag text will render itself.
Okay.
So if it wasn't like that, maybe you could see like parts of other people's names, because it's just one texture, right? And so you might be able to see other people's like names cut off at the top or the bottom. But because it's just that rectangle, it kind of like crops it exactly where we want it to be in that text atlas. So it is like very controlled in that sense.
That's great. Again, it's such a creative solution, and I haven't seen anything like that in any of the other spotlights I've done. So this is cool. You did this for the UI that's in front of the player, but you also did it for the minigame tasks, right? So can we look at some of those and how you've implemented the shaders for the tasks?
Yeah, so I think I will probably hand it off to Abril, since she handled most of those.
Okay.
I guess I can talk in the meantime. Like a lot of that setup is very similar, even though like from UI to like a 3D model, since it's all 3D models now. Essentially, that thought is we can do the same thing with a mini game, right? So whether it's a name tag or a panel with buttons on it, a lot of that same behavior can be used. Gotcha. And so, for example, if there's like a panel with buttons on it, those buttons could be colored different vertex colors, and then different behaviors could be driven through that. Yeah.
So you're really using vertex colors for a lot of the control.
Yeah.
Oh,
yeah.
Cool. So I think we're just switching now to another scene, right?
Yeah, I'm trying to find a mini game here.
Okay.
That does something similar to what we were talking about.
And then in general, I guess it's also for the same system is being used for the map, which I guess you showed us with changing the colors on the map itself, right?
Yes.
Yeah.
Yeah.
Cool.
Yeah.
Oh, there we go.
So yeah, one of the examples is like, I guess, this download minigame, since it's been shown before. But yeah, essentially I created a bunch of shader properties based off of the vertex masks that do different things. So like in this case, we can change the color of the button. There's also different states where like it animates and it doesn't animate. Again, all driven by vertex colors and masks. I believe this animation is being driven by a sprite sheet, though. Oh, that little icon is a little off. Actually, I think this is the correct one. My bad.
It's great to see it dev in real time. It's a Let's Dev now.
Ooh, that's not the right texture. There it is. So yeah, things like the fill bar and things like the different states, the different colors, those are all driven in the shader via vertex masking. So all of these like buttons and stuff all exist in the same one. Where's another one that has something similar?
Yeah, so for that like animation, for example, all those buttons are just laid out in a row in the texture.
Okay.
And Abril is just in the shader scrubbing through the UVs for that texture. So it's basically like a kind of like a sprite sheet in that sense.
I see.
Yeah.
It's a spreadsheet, but just done in the UV map, and then and flipping through them. Okay, cool.
Yeah.
But not scrolling, more like jumping to the next one, right?
Yeah.
Okay.
There is a second one, like divert power, where It's very more shader heavy where I am sort of doing things. So like in this case, the little center bar with the buttons, I am manually rotating within the shader.
Okay.
However, I think in the actual game, it like shifts between 15-degree intervals. So it's not as smooth as I'm showing here. But yeah, it's the same thing where we can change the colors. We can change which icon has the color. So if I scroll that down, we can see that it just shifts between the different colors. And then the same thing with the colors, just allowing all these different color variables for designers to essentially pick whatever they want. If they want the interaction colors to change down the line, that's possible.
And then you can also, I guess, animate, like use this to animate as well, right? For what you're doing. Okay.
Yes. This leads more into VFX, but I am using it, these exact same shader properties to sort of animate stuff. So like in this case, these screens, they're using the same logic where they're all built onto the same like mesh sitting on top of each other. But then I can go in here and animate them, and I have actual animation clips that drive the animation of these screens.
Okay.
Just going randomly.
It's awesome. And were all these shaders handwritten?
Yes.
Okay. Wonderful. And I think this is a good... Is there anything else we want to look at for the shaders, or should we jump to looking at the VFX?
I guess just add on.
Yeah, please.
I guess just add on with the shaders. Like, I think we are using a mix of just coded shaders and shader graph.
Mm-hmm. Oh, okay.
Yeah. So there, I think the caveat there was if for some of the things like the mini map, where you have a bunch of icons that we need to redraw, those need to be in code to support like GPU instancing.
Right.
But for one-off pieces with UI, we're using a lot of shader graph to drive that logic, just because we know that it in itself is going to just be that one draw call. Yeah.
Gotcha. And so, do you have any examples of the shader graphs on hand that we can look at?
Yeah, let me pull up, I guess, this admin screen, because it happens to be right here.
Perfect.
Bear with me, because this is a very giant screen. But yeah, it's a lot of very repetitive nodes, and just building up the nodes and then repeating each thing. So I guess if I zoom in on this part, this is where the main.
So I'm not
part
actually seeing the graph. I'm not sure if that's just on my end, but
I think the stream is catching up.
Oh, the stream is catching up. Gotcha.
Oh yeah, it's a little delayed.
There we go. Okay, sorry. Go ahead.
So yeah, in the shader graph, the main chunk of what's happening is where I'm, I guess, grabbing the vertex color from the mesh and splitting it and creating masks that sort of say, okay, when vertex color is, let's say blue 1, show this mesh. So there's a lot of that going on. And then there's a lot of like color swapping, color lerping, essentially to pick colors. To play animations, it's sort of, let's say if there's 4 frames, each mesh is essentially modeled out as a frame, and they each have a vertex color assigned to them. So frame 1 would be red 1, frame 4 would be red 4. And then in the shader, as I switch between those index numbers, it's essentially cycling between showing me those meshes. So it kind of looks like an animation that plays when I just start running through them really quickly. And cool. I will do animations on top of that sort of like just automatically toggle between those numbers.
Great.
Yeah, I think the complex thing here in the shader graph is a lot of the behavior, it kind of looks like, I mean, it is logic, but it's all done through math, right? So, for example, if you have a mask of something, you know it's like, let's say red 1 or something like that.
Yeah.
If you can see if it's equal to 1, then you get a 0 or a 1 as a result, right? And so usually that's just like a Boolean compare, right? Like, oh, I know this is 1 or 0. Since it evaluates to 1 or 0, then you can multiply that with something. So you can multiply something with 0, 1. And so essentially all this is a lot of checks if hey, is this there or not? Is it 0 or 1?
Yes.
And then that gets multiplied by other 0 or 1s, and eventually you get the result that you want just by multiplying all these 0 and 1s together. And so I think looking at the graph, there's like a lot of nodes and
Can look
patterns.
intimidating, but it's mostly a lot of checks, right?
Yeah, but it's just a lot of checks that kind of just evaluate to the result that we want.
Okay, great. So just for anyone watching, excuse the delay. There's just a bit of delay between what we're talking about and what's being shown on screen. But yeah, so thanks for opening up that shader graph for us. The last thing we're going to look at visual, that's more on the visual side, are the VFX. So Abril, you mentioned earlier that there are some 3D mesh VFX that you used, right, for using the Shuriken particle system.
Yeah.
So I was really curious what you built with that.
So yeah, we decided to go with 3D, mostly because, as we all know, alpha doesn't really work very well in VR, especially the closer you get to it and the more it fills up your screen. And we decided that, like, well, this is VR, might as well play with the 3D nature of it. There's a clear difference between like being in a 3D like space, like watching on a screen, versus actually being physically in there. So let me grab, is this upper engine room right here? So an example of one is right here with the smoke. These are all 3D meshes. You can actually, if I go down here to the renderer, there's a single mesh here. This little mesh, this little guy here.
Oh, nice. I love that.
That's being essentially rendered out in different sizes. So like within Shuriken, I'm going in and just changing the size, the rotation, the color, all these things to sort of make it feel like it's not the same mesh being sped out at you. And the cool thing is like there are moments where in game, like this thing blows right in your face and you get a sense of like panic and like blindness, which I think is great because you can easily like have an imposter hide behind it and pop in front of you.
That's so interesting. So is that the reason you went for the 3D mesh rather than a 2D sprite for the particles?
One reason is yes. The other is it's just a little bit more performant again, thinking on the optimization side. It's a lot more obvious as well in VR when something is a screen 2D flat image looking right at you.
Interesting. Okay.
Whereas if there's like a little bit of depth, like your perspective can see more of that. So there's a lot of stuff in here that's mostly 3D, like these lightning effects up here are also in 3D. Let me turn them on because I think they're all off. Yeah, and this is using essentially the custom shader, as I mentioned before, where they're all sitting on top of each other, all the different lightning meshes, and then they're all, in this case, they're all masked out on the UV side. So if I find the mesh, let's see, VFX, I think it's this mesh. Yeah, so if I go in here, you can see that all the lightning is sitting on top of each other, and in the UV space, oh, this is big. Let me try and shrink it. They're all sitting essentially horizontal or vertically on the UV space, and what the shader is doing is it's masking out. There's a single white bar that essentially pans across on the U axis, and as it hits one of those like UVs of the mesh, it shows that particular mesh. So it'll just look like it's animating. But in reality, they're all sitting on top of each other, just masked out.
That's such a smart trick. I love that.
And again, it gives this feel of like the lightning is real. It's like it's got mass. It's got a lot of volume to it. And things that we couldn't have done if we had just made them 2D particles.
Okay. And actually, I had a question that crossed my mind, but then I also saw it in the chat. So I guess a few people are wondering this. When the smoke comes out and you're like inside the 3D mesh, what do you see? Do you see like the inside of the texture when you're actually playing the game, or the side of the mesh, sorry?
Surprisingly, it's mostly just the white of the mesh. So like as you're kind of seeing here, that's kind of how it looks. Okay. It's just all white in your face. So I like that it really makes you feel like you are enveloped in smoke.
Okay, great. So did you have to texture the inside of the mesh as well? Like make sure the UV on the inside was also the appropriate smoke color?
No, that are actually not UV'd at all.
Okay.
The shader is essentially, I think, just a flat shader with the
That makes sense.
just
A
toon
flat color
smoke.
that changes.
It's
Yeah.
just a flat color, and the shading is determined by the lighting. So the angle of the lighting and all that is what's determining where the shadow sits. The same thing with this one. The lighting is determining where, and most I can do is just change the color of the shadow. So if I want it to have a lighter shadow, it can. It's hard to see when it's blue, but yeah, you can change the colors and stuff. I can also change the speed to make them go super fast. So if I change this to like 60, they'll go really fast. Oh, why isn't
it's
it
about to
changing?
burst.
Oh, I see. I need to change it up here. There we go. So now they'll go super fast. Or I can change it to 1, and we can see it changing between the meshes much more easier.
That's so cool. And are there any other particles that you worked on that you want to show us?
I guess I can go into oxygen, because oxygen did have some of my other VFX in there. So like this algae ground is essentially, it's all one mesh for the same reason of draw calls and whatnot. Mm-hmm. And it just has a sine wave sort of passing through it to give it the illusion of it going up and down.
Oh, nice.
I think it's this one. No, plant sway. Here it is. And it's, again, a shader graph thing where I'm just taking the mesh and sort of feeding it sine waves and specific X and Y coordinates, and then just sort of combining that all and feeding it back into the vertex portion of the shader so that it just kind of undulates up and down and looks like it's part of the thing. There is also, I believe, one of the few versions of alpha that we have. Let's see. Where are you? Here it is, VFX. So here we are. It's one of the few instances of alpha, just because we couldn't find a really good way of differentiating the oxygen air from the smoke.
Oh, interesting. Okay.
And this is also, again, I think it's the exact same little smoke mesh. Yeah, there it is. It's the exact same little dude. The only different thing that changes is the shader now has a little alpha. Where is it? Oh, it's built into the shader, or it's determined by the shuriken. So I have it here. Yeah, so here it is, the alpha. So if I make the alpha 1, it goes back to like really solid.
Right. And does that optimize things reusing the same meshes for different particles?
Yes.
Okay.
Yeah, it's a little bit more optimized just because there's less meshes to be drawn differently. And then another one that's using the exact same plant, the plant waving texture or shader is this one as well. It's just a big old plant that just has a different sine waves running through it to show the different wind strength. If I increase it, it'll look like it's shaking a lot. And there you go, we're breaking stuff already.
And is it applying to each like leaf, or is it applying to the whole thing? Is the whole plant one mesh?
The whole plant is one mesh, but I believe in the shader, let's see, plant sway. I believe in here I have a mask that is determining so that it doesn't sway the whole plant. Where is the one of these is a mask that's sort of keeping it from.
That's really nice.
From the whole thing going crazy, so that way the center of the plant kind of stays static. And the plant is also unwrapped in that way as well. I can't find it, but there is a mask in here that is UV based, unless it's this one. There it is. So I have it UV'd in the way so the plant, the leaves, everything closer to the white will be what sways more, and everything closer to the black is what will stay static.
Okay, so basically what's rooted into the soil.
Yeah, so I believe if I can find the plant, let's see.
We'll actually see that gradient on the plant itself.
Yeah, so.
Cool. By the way, everyone in chat is calling you a shader wizard.
So yeah, here's the plant, and it's UV'd kind of haphazardly, but the idea is that like the top of this is essentially all the parts that will be swaying, and everything closer to the black, as you can see, is all the base stuff, and that's what will stay static.
Gotcha.
So it kind of lines up with this, where'd it go? With this mask, essentially.
Perfect. Okay, great. So, I mean, thank you for that look. People in the chat were so excited to see all the different like creative solutions you used for the particles and VFX. I think the last section we're going to look at for today's stream, which was brought up millions of times in the chat, was how you actually implemented multiplayer and networking in your game, right? So we have two diagrams that you prepared for us. I think, Michael, you prepared these diagrams for us. And so we'll be looking at those. I think you're sharing the screen, right, Michael? Or no, actually, sorry, we're playing it on our end. We're going to play the first network image diagram.
Yep.
And yeah, there you go. So we can speak to the networking. Yeah.
Yep. So, Among Us is a multiplayer game. So you need up to 10 players are connected and all playing together. And so we were using, so in our case, we are built using Exit Games and their multiplayer solution, or networking solution, Photon Fusion. And so we have a quick diagram here of sort of how things are composed of. This is a really, really big simplification. And this isn't anything too special, but we have this idea here of like, we have a sort of a main class called the peer. And this is really important because this sort of encapsulates all the game and network connections into a single object. And this is actually not just useful for general code cleanliness and such, but also allows us, because what we do with the peer, depending on the situation, so in editor, we can not just have people connect to each other, but we also have this idea of a network simulator that was created by our technical director, Bill Roberts. Mm-hmm. And this allows us to fake we can create multiple peers in editor to debug situations where you don't need to be connected online or even have other players. You can have these sort of peers all existing in the same scene. But then these peers are connected to the network runners. And the network runner is the main online network object for your player. So from there, so you can see like the network runner is what's sort of responsible for things like your voice connection and sort of the general connecting to either you as the host, hosting other people, or you as the client connecting to the host. And just so people are clear, Among Us VR is it's a peer connected game, so the host is a single player, and all the clients connect to the host. And sort of a multiplayer lobby. The matchmaking is basically finding people who are available or created and hosted their own games and connecting people to them. So after the network runner, we start just sort of like breaking down the game into separate components.
Yeah.
So we have like the managers, we have the XR rig, which is your individual player. We have a lot of different managers that are networked to handle things such as the current game state you're in. So whether you're like in the task mode or voting mode, those are basically the two main modes for Among Us. Handling things like the mini games, the chats, the sabotage, etc. And then from the XR rig, the player, we have both you're controlling your hands, but also we're controlling your external avatar representation.
Okay.
So that's the locomotion player, and that's what other players are seeing of you. And so that what this allows us to do is, rather than having multiple network objects for the XR rig and for all your individual hands, we just have one network object that controls your entire player and visuals.
Okay.
So that's sort of the high level engineering breakdown, and Parker, is there anything else you wanted to add on to this so far?
I think the big one you already hit is just that idea that we created that fusion simulator, the network simulator that Bill Roberts made for us that helped us sort of test and debug this networked game on our own in editor as if we were playing with other players, which was just super helpful over the course of development.
Oh, so is that something we're gonna look at, or are you just telling us that was something that was built?
Oh, I guess unfortunately, there's not much to look at.
Yeah, right.
It is like, it's sort of just seeing the game in editor, but
Okay.
what the nice thing here is like you can create multiple peers, and then you can switch between the peers, so you can sort of very crudely simulate a real game. It's actually a little cumbersome,
That's
so
cool.
what you have to do is like, because you can only control one player at a time, but you can move around and you can sort of recreate like a voting scenario. Then obviously we have like internal debug tools to allow you to jump between different states, so you can immediately go into voting. You can go into testing out like as an imposter what role you're in, testing out kills, testing out different cutscenes such as the emergence, like getting kicked out of the game cutscene, etc.
So is it like simulating 10 play modes at once, basically?
Up to 10 play modes.
Up to 10 play modes.
For
Oh,
most
yeah.
things, you only need to simulate one, like usually one other player.
Right.
But there are scenarios where you might want to simulate up to 10 other players.
Okay.
Which is hilarious because you have 10 scenes essentially running all on top of each other. So
Yes, and when you're stress testing and things like that, you have to use 10 of your, because you said that you have like 10 QA people who are on board. Do you have to test it with all 10, or can you use this to simulate stress testing?
a little bit of both.
Okay.
As with all performance, we do initial profiling on editor, but obviously the editor is not a complete solution, and you want to test in device, especially we're a cross platform, so we're on the Quest, we're on the Rift, we're on Steam, so PC VR. So it's always good to, in the end, test in real build scenarios with
Okay.
up to 10 players.
Okay, great. Awesome. And if we're already done with this slide, I believe there was a second slide that goes over
Yes.
networking. So let's
Yep.
get to that. There we go.
Yeah, and this is the other important thing. So one of the key things here with any networking game is what you are doing locally versus what is happening on the host. So what is basically host or server authoritative. So you can see here, we sort of have split it up where, especially in VR, it's really important for things to be as responsive as possible.
Right.
So any lag, any delay in feedback is going to cause like a lot of, not just like it doesn't feel good, but it ends up it could cause like VR nausea or sickness, right?
Right.
So in our case, we wanted to give as much local control as possible while still maintaining game fidelity and stability. So here, for example, the XR rig, i.e. the player, and your hands and your personal role as imposter, those are all controlled by your local client. And this extends all the way to tasks. So when you're interacting with the different mini games, so whether that's the buttons or levers, it's really important for us for those levers, like when you pull the lever or you push the button, you want that to immediately respond. You don't want us to send a network confirmation or an RPC call all the way up to the server, confirm that that's possible, and then send that confirmation back down.
Yes.
But what we do have is the ultimate confirmation of like the task completion. That is handled by the network. So you can see on that side, other players, sabotages, voting in meetings, and tasks, including visuals. Those are all handled by the host in this case. So the host, as always, is going to be the final authority on what is the true state of the game. So if those are ever out of sync with each other, we fall back to defaulting what the host is seeing, and we make sure that that propagates across to all the other clients.
Right. And I see none of those things that are under networked are going to affect the player's vision or cause lag for them. It's more game state stuff. It looks like.
Yeah, exactly.
Yeah.
So and this it can actually get a little tricky here, right? Because one of the things, actually, I forgot to include this on this slide, is like our kills need to be both. We want that feeling of the kill to feel instantaneous, but we also need to confirm that kill was valid on the server. So what we have there is like the initial kill is triggered by the player, but then that confirmation of the kill and how other players see it, which is like, the classic Among Us, someone getting sliced in half. Yeah. You see like the little bone sticking out and that player flops over. That animation is triggered by the server or the host confirming that kill is a valid kill by an imposter and then propagating that down to the other players.
Got it. So the kill is local, but the validation is network.
Yes. So you as a player, when you kill someone, it feels instantaneous.
Yes.
But then what actually happens is ultimately confirmed by the server.
I see. Does that cause any issues if there's two imposters trying to kill the same person and they may both see the kill animation, but only one of them is validated? If there was a bit of lag between the two of them, or?
Yeah, Parker, you can jump here. I think what ended up working out is, in the end, when you kill, like things like resetting your cooldown timer and everything, that's all handled by the server confirmation. So even though technically it's like maybe two people killed, you only see one animation and only one person gets the cooldown. So it doesn't affect how the game ultimately plays. There might be like a slight visual discrepancy for one of the local players.
Okay.
Oh yeah, Parker.
I was just gonna hop on and sort of plus one what you're saying.
Yeah.
There might be some, in rare cases, issues that crop up when things happen super simultaneously. But anything that is sort of gameplay critical will be handled on the host and will therefore always have a sort of canonical order of operations. So the game doesn't sort of break in those scenarios. But that is something we had to sort of debug a whole lot.
I see.
Yeah, with any networking game, the edge cases of like if someone's on a really poor connection, or if there's network events being all thrown at once and they don't arrive in the order that in the same order that they were sent out. That's what we have to put in. There's a good amount of logic on the server's end to confirm and clean all that up.
Nice. Okay, some scaffolding built around those edge cases, basically. All right. And the whole system was built on Photon, right? Photon Fusion.
Yep, that is correct. So we're using Photon Fusion, and so they've a lot of this stuff, like the idea of the network runner, and they have network behaviors, which are an extension of the classic Unity mono behaviors, but are handling network instances were useful for us to get started prototyping and building the multiplayer game, basically.
Yeah. Okay, great. So again, thank you for walking us through all of this. Like the chat has been asking about the networking since we started the stream. So obviously, very hot topic. Thanks to everybody for everything you've shown us today. As we're wrapping up the stream, something I like to do with all of the creators who come on is ask them for their final takeaways or any advice they have for other developers. It's been takes a long time to build a game. There are a lot of lessons learned, a lot of challenges faced and overcome. So I'd love to hear a final takeaway from each of you. We can start with Michael.
Yeah, so I'll say, as someone who, I wasn't at the start of the project, but once I joined in, I gotta say, like, when you're developing, especially a network multiplayer game that has like a lot of systems, it's really easy to like get caught up in like the technical details. But one of the great things with the multiplayer game is you have to play it, and you have to play it with, the easiest people to play it with is with your team. And I'll say, like, especially, we started this project while the pandemic was still like really, really in full swing. But the fact that we're able to play test, to like try out new things, and we're always playing against each other, I really think it brought the team together. And so there's a lot of fun and value in building a multiplayer game. If for nothing else, you really get to learn all the other collaborators on your team and how they play and how good they are at lying, or not good at lying in a lot of cases.
There's some team building, some team breaking.
Yep.
All of the above. Okay, great. I love that one. Parker.
Yeah, so I'll give a piece of advice that's pretty general as far as game dev goes, but definitely something that came up a lot in the development of the project for me, which is when you're sort of working on a new project, never be afraid to make it sort of ugly but functional.
Okay.
So this goes into prototyping a whole lot. Yeah. Just don't worry about making the most sort of elegant, robust system in the world when you're just starting out. Just make something you can feel the vibe of what you're going for, so that you can sort of build on top of that and worry about the sort of details, the polish later on. That just helps both your own sanity, and I promise you, you'll make progress faster that way.
And I guess that takes a lot of confidence and trust in the process, right? That this will look good eventually at some point. Right now, it doesn't look, but you can trust the fun. It feels fun, and then you can add those visuals later, right?
Right, and it makes it so easier to iterate if you just sort of make the rough blocks first, if you will.
Yes. Okay. Absolutely. That's a good one. So Abril.
I was gonna say have fun, but that's what Michael Lee essentially said. But the other takeaway that I think helped us out a lot was essentially starting out optimized. I know it's like we started out low intentionally because we wanted to stay optimized. And it's much easier to go in and add extroverts later than it is to take away from it. So building out optimized really helped cut down on the amount of optimization that we had to do at the end.
Gotcha. So optimize from the ground up rather than an afterthought. That's really good. And Dan, no pressure,
yeah. I mean, I think just add on, like setting up the pipeline for the game definitely helps a lot, and I think a lot of that is just being able to communicate well with your teammates. I know a lot of the optimization stuff, it can get pretty complicated pretty quickly. So I think just making sure everyone is on board with what is happening. Everyone understands what is happening and that it all makes sense. Then it's so much easier to move forward and make progress. Yeah,
absolutely. So open communication on top as well. Great. Thank you so much. Thank you everyone for joining me, and thank you to the chat, both the chats on Twitch and YouTube. We had such an amazing turnout today, and so many questions and so much enthusiasm, and also so much mention of a cheese hat I see in the chat. And I'm not sure if that's some kind of Easter egg or some inside joke that I'm missing out on, but just want to let you guys know that the community really wants a cheese hat. So gotta give them the cheese hat. But yeah, again, we dropped some links in the chat to the Steam page, to Schell Games website. Please check all of those out. Get the game if you haven't already. Sorry, go ahead.
Oh no, yeah. If you love the hats, we have keep on sending us feedback. We love. Abril creates a lot of the hats too, actually. So.
Oh, nice.
I wanted to add that, like, I'll keep that in mind, the cheese hat, since I'm the one working on hats.
Oh, there you go.
And we have more hats coming. So.
That's fantastic. There's also apparently a request for a kebab hat. We should have been asking for hat recommendations the entire time, but apparently food is a good theme to think about.
Maybe chat's just hungry.
Maybe chat. That's a good point. It was a long stream. Absolutely. Again, thank you guys so much, and thanks to everybody in the chat. Stay tuned. Weekly on Wednesdays at noon Eastern time is when we usually go live. You'll see notifications on YouTube and Twitch. Subscribe to us on YouTube and follow us on Twitch for those notifications. All right. Thanks, everyone. Thanks again. And we'll see you soon. Ciao.